Welcome children. In the previous video, we have seen the part 1 of SHM, and in that video, we have seen up to differential equation of SHM, and we have done this example. Now, the solution of this differential equation is, so that means if you solve this differential equation, so we will be getting x is equal to a sine omega t plus or minus pi, or x is equal to a cos omega t plus or minus pi. So the general solution for this differential equation is this. That general solution we call it as general equation of SHM. So this is the general equation of SHM. So you can express SHM in terms of cos or in terms of sine. So it could be a sine omega t plus or minus, even it can be minus, or a cos omega t plus or minus pi. Now, the time period of this SHM will be 2 pi divided by omega, that you know. So, omega is called angular frequency. That angular frequency is equal to 2 pi f. So, f is frequency. F is frequency, and this frequency is reciprocal of time period. So, f is equal to 1 by t. Okay. So, now we will discuss about this general equation in detail. So, in this general equation, this x is the displacement of the particle from the mean point. When a particle executes SHM, so there will be definite path, and so the definite path will have mean point and two extreme points. So here P and Q are extreme points and O is the midpoint or mean point. Mean point is the point where the net force acting on the particle is zero. X is the displacement of the particle from the mean point. Here distance will be always measured from the main point only. So that is x. That is this x. What is this A? A is called amplitude. So A is amplitude. Amplitude so will be measured in meter or centimeter. Even displacement also will be measured from meter or centimeter. And amplitude is the maximum displacement of the particle from the main point. This is amplitude. Even this side also minus A. What is this omega t plus or minus pi? This total angle of the sine is called phase. The total angle of the sine is called phase. Phase will tell you the position of the particle and also the direction of motion. And here this pi is called initial phase. That pi is called initial phase or epoch. Initial phase or epoch will give us the information about the initial position of the particle and its direction of motion. So this is about the different quantities involved in the general equation of SHM. X, A, that entire angle of the sine, that is argument of the sine, is called phase, and that pi is called initial phase. You can express this general equation of SHM in terms of cos or sine. Tan function, cot function, e power minus x square function. So all these functions will not become SHM. Only sine function or cos function will become SHM. Okay, so once if we understand, once if we understand the general equation of SHM, now what are the different forms of general equation of SHM for different starting points? So that we see now. Suppose if the particle starts its oscillation at the mean point and if it is going towards right, then the equation of SHM is x is equal to a sine omega t. If it starts its oscillation at the same mean point and if it is going towards left, the equation of SHM is x equal to minus a sine omega t. If it starts at the positive extreme point, then the equation is a cos omega t. If it starts at negative extreme point, it is minus a cos omega t. Children, how we get this equation? So I'll give you for one point. Say the particle starts its oscillation at the positive extreme point. How do you get that a cos omega t? I'll tell you for one point, and we'll be solving for the general equation of a system for any other point when it starts at x equal to a by 2, when it starts at x equal to a by root 2, and if it is going towards left and if it is going towards right, and all that we see. Now, for this point, so we'll solve that. That is, why do you get x is equal to a cos omega t if the particle starts at positive extreme point at t equal to 0? At t equal to 0, if the particle is here, so what is the displacement of the particle a? So displacement of the particle is a. So always remember, children, displacement will be measured from the main point. For that particle which is executing a session, the main point will become the origin. So the general equation of SHM is x is equal to a sine omega t plus pi. Take this general equation. At t equal to 0, x is equal to a. You substitute that. So a is equal to a sine 0 plus pi. Why 0? T equal to 0. So a will be cancelled here. You will get sine pi is equal to 1. That implies pi is equal to that pi. The initial phase will be equal to pi by 2. Once we get pi by 2 as initial phase, that substitute that initial phase here. So we will get x is equal to a sine omega t plus 90 or pi by 2. Sine 90 plus something is cos. So x is equal to a cos omega t. So the same approach you can follow to find the general equation of a system for any starting point. For any starting point, the same approach you can follow. So we see that in the next example. See this example. Write the general equation of a system if the particle starts its oscillation at x equal to a by 2 and is going towards right. Children, here the direction of motion is also important for initial point, because so each point in the path will have two faces. Why each point in the path will have two faces? So in one complete oscillation, each point will be crossed by the particle twice. Each point will be crossed by the particle twice. Okay? Suppose the particle starts its oscillation here, it goes towards right and it comes towards left, and again it reaches the same point. This is one oscillation. You concentrate on one particular point. That means that point is crossed by the particle twice. Concentrate any other point. That point will be crossed by the particle twice. While going towards right here, going towards left. Going towards left here, going towards right. So each point will have two faces, remember. That's why at t equal to 0, the direction of motion is also important. Each point on the path will have two faces except extreme points. Extreme points will have only one face. So remember this. So now, here the particle is going towards right at t equal to 0 and it has displacement a by 2. So the general equation of SHM is x is equal to a sine omega t plus pi. At t equal to 0, x is equal to a by 2. So substitute that a by 2 is equal to a sine 0 plus pi. So a will be cancelled here. 1 by 2 is equal to sine pi. That implies pi is equal to, when sine pi is equal to 1 by 2. So pi will be equal to pi by 6 and pi minus pi by 6, that is pi by 6. Now which angle we should consider? If the particle is going towards right, you consider the first angle, first phase. If the particle is going towards left, so at the same point at t equal to 0, then you consider the second angle. Now you consider the first angle. So when you consider the first angle, so the equation will be x is equal to a sine omega t plus pi by 6. So this is, so x here I'll write x is equal to a sine omega t plus pi by 6. So this is the general equation of a system for that starting point.